with radicals. I think multiplying radicals is a little bit simpler than adding or subtracting radicals. So hopefully you guys feel the same way. It's very, very basic though. So let's start with something easy. We'll start with the smallest stuff. Square root of 3, square root of 6. So the reason I think that this is the easier one is because you already know how to factor, which means you already know how to break one down. So why not being able to piece it back together? You know, before when we had something like, oh, hey, I'm going to give you the square root of 24. And you knew to be able to break it down to square root of 4 and square root of 6. So can't you piece that back together to make square root of 24 again? Right? You would just multiply them. So if they're under a house, you multiply those values together. If they're in front of the house, that's what I call the root, then you would multiply the coefficients together. Here, they don't have any coefficients. It's just simply two radicals that you're going to multiply together. So put it underneath one radical, one root, and you're just multiplying 3 times 6. And that's going to give you the square root of 18. Now, you're not done. They want it to be as simplified as possible. Is square root of 18 able to be factored? Yes. This is one that we have done many, many, many times. What are the two factors that we use when breaking 18 down? 9 and 2. Good. So square root of 9 and square root of 2. Square root of 9 obviously is the perfect square. Square root of 9 is the perfect square. We put 3 and then square root of 2. And there's our final answer. We're done. Okay, let's try another one. We have the square root of 8 and square root of 6. So again, square root of 8 and square root of 6, I'm first going to go ahead and just multiply those together. So that's going to give me the square root of 8 times 6. And what's 8 times 6, guys? 48. So we get square root of 48. 48 can be broken down. We've done this one many, many times. What are the factors for 48 that we use, Leo? 16 and 3. Notice that we tend to do the same ones over and over and over again. So at some point, you might want to memorize some of these. That, oh, 18 can be broken down into 9 and 2. 48 is 16 and 3. 27 is 9 and 3. You know, memorize those things. 75 is 25 and 3. Get those ones that we seem to use the most memorized. It makes it a lot simpler for you. Okay? If you need to make flashcards of some of those, that's a pretty easy thing to do. So having your perfect squares memorized along with some of those, you know, basic non-perfect squares, it makes it a lot simpler for you. All right, so square root of 16 is the perfect square. What is square root of 16? 4. So we get 4 square roots of 3. And that's our final answer. Okay? How about you guys try a couple of them on your own? Remember, you only simplify if they can be simplified at the end. But you always want to make sure that you get it down to where it's as far as you can possibly go. All right, who can tell me what they got for problem number 3? Square root of 2 times square root of 3. What did you get? Oh, come on, guys. This is an easy, easy one. Eric? Square root of 6, that's all it can be. You can't even simplify it any further than that. You're just going to multiply the 2 times the 3 and keep it under one radical house and get square root of 6, and that's as simplified as you can go because you cannot break square root of 6 up any further. Okay, there are no perfect squares that go into there other than the square root of 1. What about problem number 4? Problem number 4, David? Square root of 35. Again, that's another one that can't be simplified any further. So you're just going to multiply the 5 times the 7, and that's going to give you square root of 35. And that is as simplified as it's going to get because there are no perfect squares that go into 35 other than square root of 1. What about for problem number 5, Bonnie? 2 square root of 6. Okay, so when we do this one, we're going to do 3 times the 8, which is going to give us a square root of 24. And then square root of 24 can be broken down. That's another one of those ones that is a value or a square root that we should know how to break down immediately as the square root of 4 and the square root of 6. Square root of 4 is that perfect square, and square root of 4 gives us a 2, so we get 2 square roots of 6. 2 square root of 6. Okay, and then the square root of 14 and square root of 7. Who can tell me what that one is, Jair? 7 square roots of 2. Good. So when we multiply 14 and 7 together, we're going to get 98. And 98 is another one of those that we have worked out many, many, many times, but it always seems to be the one that trips you guys up the most. And I think it's because it's the square root of 49. And not often do we work with values of 49. But 49 is a perfect square. 49 times 2 gives us that 98. And again, 49 is the perfect square. So we get 7 square root of 2. Okay, pretty simple, right? Okay, let's kick it up a notch then. So sometimes you're going to have variables involved as, or, well, do I want to do the variable ones yet? Actually, no, we're going to do a little bit of practice where we're going to have exponent involved. And that's a simple one as well. Okay, so let's say that we have 5 square root of 3, and we're going to raise it to the second power. 5 square root of 3 to the second power. Okay, this is a very basic, very simple process as well, because if it's raised to the second power, it just means that this whole thing is going to get repeated how many times? 2 times. That's all that's going to happen. We're just going to repeat it twice. Let me see how I broke that down for you guys. There we go. Okay, so for here, we're just going to double it up. We're going to have 5 square root of 3 times 5 square root of 3. Okay, now up here we already knew that if it's under a square root, we're going to multiply them together. But then the same thing goes for what's not under a square root. So this 5 and this 5 are going to get multiplied together. And then what's under the square roots are going to get multiplied together. 3 times 3. Well, what's 5 times 5? 25. And what's 3 times 3? 9. So we get square root of 9. But oh, lo and behold, isn't 9 a perfect square? Yeah. 9 is a perfect square. So we really get 25 times what? Times 3. And what's 25 times 3? 75. Okay? So again, really simple, easy stuff here. Can I switch the page? Okay. So I'm going to give you a couple to try on your own. You have 2 square root of 5 raised to the second power. Six square root of 7 raised to the second power. Go ahead and try those two on your own. Tell me what they got for problem number 8. We had 2 square root of 5 raised to the second power. Leo, what did you get? 20. Very good. So when we're taking a look here, again, we're just going to be doing 2 square root of 5 times 2 square root of 5. We're going to focus first on the coefficients. So 2 times 2 is going to give us 4. And then the square root of 5 times the square root of 5 gives us a square root of 25. And square root of 25 is a perfect square, right? 25, square root of 25 is just 5, so 4 times 5 is going to give us 20. Okay? All right, let's take a look at problem number 9. Problem number 9, 6 square root of 7 raised to the second power. What did we get there, Amy? 252. Very good. So again, we're going to do 6 square root of 7 times 6 square root of 7, which means we're focusing on just multiplying the 6 times 6. 6 times 6 is going to give us 36. And then the square root of 7 times square root of 7, 7 times 7 is 49. And we've created a perfect square here. Square root of 49 is just the 7. So that means you're going to get 36 times 7. And 36 times 7 is going to be, oops, wrong color, 252. Okay? All right, so now let's move on to some variables being involved. So let's say that we've got a problem like the following. We have 2 square root of 8x times the square root of 4x. Okay, 2 square roots of 8x times the square root of 4x. So when we're multiplying those together, again, you're focusing on multiplying what is outside of the root with whatever's outside, and what's inside with the root, multiplying those for the inside. So here we only have one value that's on the outside. We only have the 2 that's on the outside. So we're going to go ahead and remain keeping that on the outside and multiply like we would normally do here on the inside. So we're going to do 8x times 4x. So I'm going to go ahead and split this up where I'm just going to focus on doing 8 times 4 under one house, and then x times x under a different house. Okay, I'm going to keep the numbers with the numbers and the variables with the variables. And of course that 2 is still here out in the front. Well, what's 8 times 4? 32. So I get the square root of 32 here. And what's x times x? Come on, guys, you just did that. X to the second power. You guys just did that last semester. X to the second power. It's x squared. Here, I'll zoom in a little bit easier. Okay? Okay, so we have 2 square root of 32 square root of x squared. So now what I want to do is I want to try and simplify what I can. Square root of 32, it's another one of those that should be memorized by now. How can we break 32 up? 16 and 2. Square root of 16, square root of 2. Okay, so I have my 2 that's out in the front. I have square root of 16, square root of 2. And then square root of x squared, that's a perfect square. How do I know that that's a perfect square again? How do I know when a variable is a perfect square? What kind of exponent does it need to have? An even number. If it has an even numbered exponent, it makes it a perfect square. So I'm going to go ahead and put that in a pink so I know that that's a perfect square. Okay, square root of 16 is also a perfect square. So I'm going to go ahead and simplify these things. I'm going to get 2 times 4, because the square root of 16 is a 4. And I'm going to go ahead and do the square root of x squared. What is the square root of x squared? Just x, right? All we have to do is take that variable and divide it by 2. Take the exponent of the variable, divide it by 2, and that becomes the new exponent. We've now gotten rid of the square root. Okay, square root of 2, though, still happens to be remaining here, so I'm going to go ahead and bring that out in the front. I can't simplify that any further. What I can simplify, though, is right here. What is 2 times 4x? 8x. So we get 8x square root of 2. And that's it. 8x square root of 2. Let's try another one. Okay, 3 times the square root of 2m times the square root of 14m. Okay, that 3 is going to stay on the outside. And we're going to put all of this under one house. We've got the 2m times 14m. Now, I want to go ahead and just bring the numbers under one roof. So it's going to be the square root of 2 times 14. And I'm going to bring the variables under another roof. Square root of m times m. What's 2 times 14? 28. So we get the square root of 28. And then m times m is m squared. Okay, let's break 28 up. What perfect square can go into 28? 4. So we have square root of 4 and square root of 7. Okay, and square root of 4 is a perfect square. Square root of m squared is already a perfect square, so I'm going to go ahead and put that back in pink. Okay, so I get 3 times 2, and then the square root of m squared is m. Square root of 7 is just going to get brought down by itself because it's not perfect, square root of 7. And then what is 3 times 2m? 6m. So we get 6m square root of 7. 6m square root of 7. Okay, get that copied down. We're going to switch over to the next page. Lots of examples that I'm showing you here, so that way you have lots of stuff to look off of for your assignment. That was problem, what, 11? Was that number 11? Okay, so number 12, we'll try this one. Okay, 5 square roots of 15x to the third times 2 square roots of 5x to the fifth. So we'll do this one again together. We're going to focus first on doing the 5 times the 2. I think I wanted to do that in pink. Oops. So we'll have the 5 times the 2. And then all of our values. I'm going to go ahead and just break it down to where I'm going to do the numbers together and then the variables in a separate one, since we already know we're going to split them up. Okay, square root of 15 times square root of 5 will just be 15 times 5. x to the third times x to the fifth, x to the third times x to the fifth. Okay, what's 5 times 2? 10. Good. Square root of 15 times 5. What's 15 times 5? 75. And then what's x to the third times x to the fifth? X to what power? The 8th, not the 15th. You don't multiply the exponents, you add the exponents. Remember back in first semester, if you're multiplying and the base is the same, you add those exponents. So if you need to put a little plus sign up here to remind yourself that you are adding those exponents to get x to the 8th power. Okay, let's go ahead and break these down. Square root of 75, we've done it so many times. What is it? Very good, 25 and 3. So we have 10, square root of 25, square root of 3. And then x to the 8th, is that perfect or not perfect? Perfect, right? It's even. It's even. It's already a perfect square. So I'm going to go ahead and just write it in pink because it's already perfect. I'm going to put x to the 8th power in my square root. Okay, let's go ahead and simplify. 10 square root of 25 is 5. Square root of x to the 8th is x to the 4th. Remember, you're going to divide that by 2. When you're taking the square root, you're going to divide that root or that exponent by 2. You get x to the 4th. Okay, and that square root of 3 is going to come down. Square root of 3 is going to come on down. 10 times 5 times x to the 4th is going to give us 50 x to the 4th, and then square root of 3. 50 x to the 4th, square root of 3. Okay, we have 4 square root of 12x to the 3rd times 5 square root of x, 8x to the 4th. Again, we're going to focus on multiplying what's on the outside first. We're going to do 4 times 5, which is going to give us 20. Then we're going to multiply our numbers inside the roots together. So we have 12 times 8, which is going to give us 96. And then we're going to have our variables multiplied together. We've got x to the 3rd times x to the 4th, which is going to give us x to the 7th, right? You're going to add those exponents together. You're adding those exponents together and get x to the 7th. Okay, so 20 we already know is going to remain on the outside. Let's break 96 up. What can we break it up into? Jair? Not 49 and 2. That would be 98. 96 is going to be what, Con? 16 and 6. Very good. Square root of 16 and square root of 6. Now, x to the 7th is not a perfect square, so we're going to break it up. We're going to break it up into the square root of x to the 6th and square root of x. Remember, we pull one of the x's out so that we're left with an even number x. Okay, so now we've got our 20. Our square root of 16 is 4. Our square root of x to the 6th is x to the 3rd. Then we've got our non-perfect squares. We've got square root of 6 and we've got square root of x. And just piece it all together. 20 times 4 is going to give us 80 times x to the 3rd is x to the 3rd. So we get 80 x to the 3rd on the outside. And on the inside of the radical is just that 6x. Okay, there's one more type of question that I want to show you, which is using distributive property. And I'm just going to show it to you one example because we don't have a whole lot of time, but it's a pretty simple concept. If we had something like the square root of 2, and then in parentheses we had something like 5 plus the square root of 12. Distributive property states that you're going to take what's on the outside, and I'm going to use my purple for this one. You're going to take what's on the outside and you're going to multiply it to each component on the inside. Take what's on the outside, multiply it to each component that would be on the inside. Okay? So when we do that, that's going to give us 5 times the square root of 2. Notice I'm putting the 5 in the front because it's not a perfect square. It's not under a square root, so I'm going to put it in the front. These both are square roots, so we're going to have square root of 2 times the square root of 12. What is square root of 2 times square root of 12 going to give us? Square root of 24. Good. 5 times the square root of 2 is just going to be 5 square roots of 2. Now, I can't combine those together because they're not like radicals. However, I can still simplify that 24. What can 24 be broken down by? 6 and 4. Okay, square root of 4, square root of 6. Okay, so we get 5 square root of 2 plus square root of 4 is 2, and then square root of 6. And that's as simplified as it's going to get. You'll have a few problems similar to that as well. Okay? You do have an assignment. It is a worksheet front and back, and it is going to be checked tomorrow. Okay? Stop the notes.